Welcome to the third part of our lesson on Java arrays, which focuses on deepening your knowledge of Java arrays by applying them in a wider variety of situations than the two earlier parts of this lesson. After completing this lesson, you will understand the concept of quick array initialization and when it can be utilized. You will also recognize how to pass a Java array as a parameter to a method and how to use an array as the return value of a method. In addition, you will learn about the arrays class in the Java collections framework and become familiar with how its methods can be used to manipulate arrays by sorting, searching, copying, and filling their contents. Finally, you will know how arrays of objects work and why they require a two-step initialization. In this lecture, we are going to continue our exploration of Java arrays by considering topics such as passing arrays as parameters to a method, or methods that return arrays to the caller, and the arrays class that contains several helper functions. To start with, we will look at quick array initialization. It is possible to create and initialize an array in a single step. Rather than specifying the new operation, you can simply list the values you want the array to have in a comma-separated list inside curly braces. This will create the array and initialize it with the given values in one step. This is very useful when you know at compile time what values you want the array to have. For example, you are creating a string array of 7 elements where each element will hold the name of a day of the week, i.e. the first element is the string Sunday and the second is the string Monday, etc. Note that when you use this quick initialization that you do not need to specify the array size, since the compiler is able to figure it out by counting the supplied values. Next, we will consider passing entire arrays as parameters to a method. To do this, we must declare that the method receives a parameter that is an array type. This is similar to declaring a variable that is an array type. You specify the type of the parameter with empty square brackets after the base type, and then you give the parameter a name. Then to call this method, you must apply an array object for the given parameter. You can do this by simply giving the name of an array variable. Note that at the call site, we do not need to use any square brackets. Here is the full code for the snippets given on the previous slide. The method average is an example of a method that takes an integer array as a parameter, and the method process contains a call to that method. Note that the parameter declaration does not specify an array length, and thus the method average can receive an integer array of any length and compute the average of all the values contained inside the array. Since an array is an object, the called method receives a reference to the object, and thus any changes that are made to the array will be seen by the caller when the method returns. This will be discussed in greater detail in a later module when you learn about passing objects to methods. In addition to passing an entire array to a method can return an entire array to its caller. This requires that the method has a return type that is an array type, again, a type that uses empty square brackets. Then the method must have an array to return. It can either be an array that is created by the method or an array that the method receives as a parameter, and the method simply specifies the array it wants to have returned in its return statement. And finally, the caller of the method needs to assign the return value to an array variable of the correct type. Here is an example of a method that returns an array. This method, named mirror, accepts an integer array as a parameter and returns an integer array that contains all the data from the parameter array in a mirrored fashion, i.e., if the parameter array contains the values 3, 8, 10, and 4, the returned array will contain the values 3, 8, 10, 4, 4, 10, 8, and 3. Looking at the code, the first thing that the method does is to create a local array that is twice as large as the parameter array. It then copies each element from the parameter array into 2 elements of the local array, one element offset from the front of the array and the other element offset from the rear of the array, thus creating the desired mirror pattern. And then finally, the entire array is returned to the caller. When using a method that returns an array, you need to assign the return value to an appropriate array variable. For example, if we were to call the mirror method that we defined on the previous slide, we would want to assign the return value to a variable that was declared to be an integer array. In the code that is shown, we assign the returned result to the integer array variable named reflection. Note that this code does not perform a new operation to create an array for the variable reflection, and that is because the method mirror performs the new operation for us. As has been mentioned before, arrays are objects. However, they do not have many useful methods available inside the array object themselves. To help address this, Java has the arrays class that contains a collection of static helper methods that operate on arrays, similar to how the math class has a collection of static helper methods that operate on numbers. Here are a few of the more popular methods from the arrays class. The toString method will return a printable string representation of the array. The equals method will determine if two arrays are identical. The fill method will assign a new value to all the array elements. The sort method will arrange the elements into sorted order. And the binary search method will search an array for a value and return its index if the value is found. Or it will return a negative integer, which is never a valid index, if the value is not found. For binary search to work, the array being searched must already be sorted. The arrays class is located in the java.utils package, and so if you want to use it, you must include an import java.util.asterisk statement near the top of your Java file. Let's consider this example that uses a couple of the methods from the arrays class. In this problem, we want to return the median value from a set of numbers, where the median is defined to be the middle number when the numbers have been sorted. To solve this problem, we will first make a copy of the array so that we do not modify the original array. This step could be skipped if the caller does not mind us sorting their array. After making the copy, we will sort the array. We can then easily report the median value, which is the middle value of an odd length array, or the average of the two middle values for an even length array. And here's our method median that receives an integer array as a parameter and returns a double value. We return a double value since we might be taking the average of two integer values. The method starts by making a copy of the parameter array by calling the copyOf method of the arrays class. This method will make a copy of the parameter array with a number of elements specified by the second parameter. In this case, we are making a complete copy of the array named numbers. After the copy has been made, we sort the copy by calling the arrays.sort method. We calculate the midpoint of the array using integer division, and then we determine if the array has an even or odd length. If the length is even, we return the average of the two middle elements. In this case, we divide by 2.0 to get floating point division rather than integer division. If the length is odd, we simply return the middle element of the sorted array. For our final topic on arrays, let's briefly discuss arrays of objects. As mentioned earlier, when an array is created, its elements are initialized to the 0 equivalent value for the base type of the array. For arrays of object types, this initialization value is a special value called null. The null value simply means that there is no object yet. For example, if we create an array called coordinate that is an array of 3 elements of type point, all 3 elements will be initialized to the value null. Before we can use this array, we need to replace all the null values with actual point objects. Thus, arrays of object type require a 2-step initialization. In the first step, you create the array object itself, and then in the second step, you create an object of the base type for each element of the array. In the code sample, after creating the array called coordinate, which is the first step, we then perform the second step in a loop that creates an actual point object for element 0, then element 1, and finally element 2. We will conclude this lesson by introducing the concept of a multidimensional array. So far, all the arrays that we have considered in this class were one-dimensional arrays. But Java also supports multidimensional arrays, the simplest being the 2-dimensional matrix. But higher dimension arrays are also possible. When declaring such arrays, each additional pair of square brackets indicates another dimension of the array. Here's an example of a 3-dimensional integer array that is 3 by 5 by 2. We do not have time in this class to go into multidimensional arrays other than to tell you that they exist. The third and final part of this lesson focused on deepening your knowledge of Java arrays. Now that you have completed this part of the lesson, you should understand the concept of quick array initialization and when it can be utilized. You should also recognize how to pass a Java array as a parameter to a method and how to use an array as the return value of a method. In addition, you should have learned about the arrays class in the Java Collections framework and become familiar with the methods it provides to sort, search, copy, and fill the contents of an array. Finally, you should know how arrays of objects work and why they require a two-step initialization.